Roughly 650 light-years away, hidden within a familiar corner of the night sky, a cosmic catastrophe is quietly counting down. When it finally erupts, it will release an immense storm of blazing radiation, superheated plasma, and stellar debris that will surge outward across the Milky Way at unimaginable speeds, scorching and tearing through everything caught in its reach. Worlds orbiting too near the blast will not survive intact. Their crusts liquefied into oceans of magma, their atmospheres violently stripped away, their surfaces shattered beneath the force of the explosion. Entire planetary systems could be transformed in a matter of moments. What makes this celestial threat so unsettling is not its distance, but its visibility. This stellar giant is close enough that anyone can find it simply by looking up into the night sky. No telescope is required. It burns as one of the brightest and most recognizable stars above Earth, glowing with a deep reddish hue in the constellation Orion. That star is Betelgeuse, the nearest red supergiant to our solar system, and astronomers believe it is living through the final chapter of its life. Sooner or later, perhaps tomorrow or perhaps thousands of years from now, Betelgeuse will collapse and explode in a titanic supernova, briefly shining brighter than entire galaxies and forever changing the region of space around it. For centuries, we've tracked Betelgeuse, a star so mind-bogglingly huge it could swallow our entire inner solar system. But recently, it started acting up. It dimmed so dramatically we thought it might be about to explode. It pulses and writhes in ways that have tied our best scientific models in knots. For years, Betelgeuse has baffled scientists. It dims, it brightens, and some observations suggest it's spinning impossibly fast. So, what is really going on inside this stellar monster? Well, we finally have an answer. It's not one single thing, but a cascade of violent events that together tell a story wilder than anyone imagined. To get a handle on the mystery, you first have to understand the beast. Betelgeuse isn't just any star. It's a red supergiant. Think of it as a star in its final, glorious, and chaotic phase of life. It has burned through the hydrogen in its core and swelled to an almost unbelievable size. If you swapped our sun with Betelgeuse, its surface would stretch out past Mars, maybe even to the orbit of Jupiter. It's a celestial monster on borrowed time, destined to end its life in a supernova explosion. Because it's one of the closest red supergiants to us, Betelgeuse gives us a front-row seat to the death of a massive star. But this star isn't going quietly. It's volatile, unpredictable, and its behavior has been a source of major scientific debate. We've known for over a century that Betelgeuse is a variable star, meaning its brightness changes. Astronomers charted a semi-regular pulse, a kind of stellar heartbeat, that causes it to brighten and dim roughly every 400 days. This was understood as the natural breathing of the star, caused by giant convection cells, like water boiling in a pot, but on a scale larger than our solar system. But there was another, ghostlier rhythm in the data, a faint cycle that repeated every 2,170 days, or just under 6 years. This long secondary period was a complete enigma. What could make a star fluctuate on that kind of timescale? For decades, it was a nagging question mark. Then came the Great Dimming. In late 2019 and into 2020, Betelgeuse began to fade, fast. It lost more than 2/3 of its usual brightness, getting so faint you could see the change with your own eyes. Orion's shoulder, once a blazing red beacon, looked strangely weak. The astronomy world was buzzing. Was this it? Was the giant finally about to blow? Telescopes like the Hubble were scrambled to get a closer look, and they gave us an answer. It seems Betelgeuse had a colossal outburst, a surface mass ejection that blasted a huge chunk of its own surface into space. This blob of plasma traveled for millions of miles, cooled down and condensed into a massive cloud of dust that acted like a cosmic smokescreen, blocking the star's light from our view. By April 2020, the dust cloud cleared, and the star went back to normal. Mystery solved, right? Not quite. The dust cloud explained the dimming, but it didn't explain what caused such a perfectly timed, massive sneeze. and it still didn't solve the riddle of the mysterious 6-year cycle. The pieces were on the table, but they just didn't fit. To solve this, scientists had to consider every possibility, and two main suspects emerged to explain Betelgeuse's strange behavior: a secret partner in crime, or a case of mistaken identity. The first suspect is a hidden companion star. For years, this was just a theory, because finding a tiny star next to a blazingly bright giant like Betelgeuse is like trying to spot a firefly next to a searchlight. But the theory is compelling. A companion star orbiting every 6 years would perfectly explain the mysterious long secondary period. Its gravity would tug on Betelgeuse's bloated atmosphere, causing ripples and disturbances that we see as regular dimming. The 6-year pulse wouldn't be a feature of Betelgeuse itself, but the rhythm of a hidden cosmic dance. Then there's the second mystery: Betelgeuse's impossible spin. When a star balloons into a supergiant, it should slow down, just like an ice skater who extends their arms. It's a basic law of physics. Yet some observations clocked Betelgeuse spinning at a blistering 5 kilometers per second, way too fast for a star of its size. This led to a wild theory. Maybe Betelgeuse once swallowed a smaller companion star. As it consumed its neighbor, it would have absorbed its orbital energy, spinning itself up like a top. This would explain the speed, but it's a pretty violent solution. But what if the star isn't spinning that fast at all? A newer theory suggests the spin might just be an illusion. Betelgeuse's surface is a chaotic, boiling mess of massive gas bubbles rising and falling. Recent simulations have shown that if a giant bubble is rising on one side of the star, while another is falling on the other, it can create a light pattern that looks almost identical to a fast rotation. In over 90% of the simulations, this boiling motion tricked observers into thinking the star was spinning rapidly. It might not be a high-speed star, but just a very, very turbulent one, chasing down clues written in starlight across hundreds of years. It's what makes astronomy such an incredible detective story. If you enjoy piecing together the universe's biggest puzzles, do us a favor and subscribe and hit that notification bell. We're always digging into the latest cosmic mysteries, and you won't want to miss where we're heading next. Now, back to the case of the misbehaving star. So we have a star that burped a giant dust cloud, a mysterious 6-year pulse, and a spin that's either impossibly fast or an incredible illusion. How do we connect the dots? This is where it gets really interesting, because all these clues might be linked. Let's go back to the Great Dimming. The cause was a massive outburst of plasma. But what triggered it? If the hidden companion theory is correct, it provides the perfect trigger. Imagine the smaller star's orbit carrying it through a particularly dense part of Betelgeuse's atmosphere. Its gravity could have been the final nudge that destabilized a massive convection cell, launching all that material into space. It would have been a perfect storm: Betelgeuse's own internal volatility combined with a gravitational kick from an unseen partner. This unified theory, where a hidden companion explains both the 6-year cycle and the Great Dimming, is incredibly compelling. It neatly ties together the star's two most bizarre behaviors. But what about the spin? If the rapid rotation is just an illusion caused by boiling, then we don't need the dramatic, swallowed companion theory. The star can be spinning normally, while the companion and its own internal chaos explain everything else. This is the frontier of science in action. We have multiple competing theories, each explaining a different piece of the puzzle. The idea of a hidden companion stirring the pot is gaining a lot of ground, but the case isn't closed. Scientists are still fiercely debating whether Betelgeuse is a solo act with a bizarrely turbulent interior, or if it's been hiding a partner all along. So what does this all mean? The story of Betelgeuse has become way more complex, and honestly, way cooler. For a while, we saw it as a lone, unstable star just waiting to explode. Every dimming was a potential death rattle. Now, we understand it as either a deeply complex single star with physics we're just beginning to grasp, or a dynamic binary system. And this doesn't mean Betelgeuse won't go supernova. Its fate is sealed. It is still a massive star at the end of its life, and one day it will collapse in a spectacular explosion. When it does, it could shine as brightly as the half moon and be visible during the day here on Earth. Ironically, all these new clues make it even harder to predict when the final curtain will fall. A companion star could speed up or slow down its evolution. We now have more variables in the equation than ever before. This is a powerful lesson in how science works. The universe is almost always more intricate than our first guesses suggest. Betelgeuse, the giant we thought we knew, was hiding its biggest secrets in plain sight, masked by its own brilliant light. The next time you look up at Orion and see that familiar reddish glow on his shoulder, remember what you're really seeing: a cosmic cold case that we are finally starting to crack. It's not just a dying star anymore. It's the scene of a cosmic tantrum, a story of violent outbursts, a possible phantom companion, and mysteries that we are getting closer to solving with every new observation.